Hello everyone and good day. I am Sam Bashir and today we're going to be making an experiment, and this experiment is called telepathy. So it's about intermolecular forces of attraction. So the materials that we need are water, Elmer's glue, two plastic cups, baking soda, popsicle stick, and food coloring. So food coloring is actually optional, so it's okay to not use it. So let us start with our experiment. So the first thing that we're going to do is we're going to mix the water and glue. So 20 ml of water and also 20 ml of Elmer's glue. So in this experiment, we're going to investigate what effect do intermolecular forces have on the properties of a substance. So we will observe the effects of changing intermolecular forces on the properties of a substance. So the objective of this experiment is to cross-link a polymer and observe the changes in the physical properties as a result of this cross-linking. So the changes in physical properties of a cross-linked polymer are also studied as the temperature is varied. So fun fact about real-world connections: the manufacture of synthetic fabrics, plastics, and rubbers are all based on the same science as this activity. So now we're going to add water to the another cup, and we're going to add 1 tablespoon of baking soda so that we will have our baking soda water solution. And now we're going to mix the water and the baking soda. And after mixing them, we're going to put them to our glue water solution. So we have to make sure that our glue water solution is slimy. So if it's not slimy, we can add some glue or baking soda. And now I'm going to add our baking soda water solution to our glue water solution. And we're going to wait or mix them until it gets slimy. So while mixing our solutions, let us talk about the review of scientific principles of these activities. So if a substance springs back to its original shape after being twisted, pulled, or compressed, it is most likely a type of polymer called an elastomer. So the elastomer has elastic properties, so it will recover its original size and shape after being deformed. An example of an elastomer is rubber bands or a car tire. So after that, I add food coloring. So as I've said earlier, food coloring is not required and it can be messy. So it is not advisable, but on my case, I did use a food coloring so that it will look more fun. Oh, I add some food coloring for it to look more orange. So when it becomes slimy, we're now going to knead it with our hands. So let's knead it with our hands. So let's stick it first, but it will soon mix with larger quantity with which we're working. So let's continue knead until the desired consistency is reached. And finally, we've reached the desired consistency. So it is stretchable. So let's try to bounce it. So it's not bouncing, so I think I will knead it more. So until I reached the desired consistency. So I really thought I've reached the desired consistency, but I guess I didn't. So I'm going to knead it more until I reached the desired consistency. So finally, I guess I've reached the desired consistency, so let's try pausing it from 30 centimeters. So it reached 12 centimeters rather. So now let's stretch it slowly. So as you can see, it is stretching, and let's form a ball again, and let's try to stretch it quickly. So as you can see, it breaks. So yeah, that's it, it breaks. Now we're going to try placing the silly putty on some regular newsprint, and we're going to place it out firmly. So as you can see, the ink from the newspaper transferred to our silly putty. Now we're going to do the same process to the comic section of the newspaper. So it's Donald Trump. We're going to do the same thing that we did before. So I pressed it. So as you can see, nothing happened. The ink from the comic section didn't come to our silly putty. So